Hi, everybody. Sorry, that took me a second. My menu disappeared. Okay, this is 6.7. This is solving radical equations. I am going to give you fair warning here. This section gets a little complex. You just have to go step by step by step, just like solving equations is. So be patient. If you need to rewatch things, do that, okay? So just right off the bat, an equation with more than one or more radicals is a radical equation if there's a variable in it. Remember, we solve equations with equal signs. When they are not have equal signs, they're called expressions, and we don't solve those. So here are the steps. The first step is to isolate the radical. What that means is you want whatever radical on this side, everything else over there, period. That's the job. Raise each side of the equation to the power equal to the index of the radical. So basically, if it's a square root, you're going to square both sides. If it's a cube root, you're going to cube both sides. If it's a fourth root, you're going to fourth root both sides, whatever. And then you're going to solve what's left. Sometimes you get to that point and you're solving, and there's still a radical left. So you do that whole process again. And then you have to check. This has a little star on it for a reason. You have to check the solutions, particularly when it's raised to an even power, because sometimes when you have something raised to an even power, you'll get a negative as an answer, or you'll get an answer that will make what's underneath the radical negative, and you'll have to say, oops, that one doesn't work, it's not real. So you really do, I know that you hate to check, you just want them to be done, but you really do have to check. So let's start with this one. This one says radical p plus 5 equals 9. Well, so the first step is isolate the radical. That means I want radical on one side, all the other stuff on the other. So I got radical p equals 4. The next step was to raise both sides to the power equal to the index of the radical. So this is a square root, so I'm going to square both sides. That makes, if I square radical p, I just get p back. If I square 4, I get 16. The answer is 16. If I put 16 under here, radical 16 plus 5, does that equal 9? Well, radical 16 is 4. It sure does. So that's good. Here's another one. You try this one. This is just like the one we just did. X should equal 25, and then you should, oh, not negative 25, positive 25. And then make sure it works. It does, but you should still check. All right, we're going to try this one. This is a little more complicated, but the steps are exactly the same. So I'm going to isolate the radical first. I'm going to get rid of this 2 to the other side. Okay, I cannot solve this unless the radical is isolated. Can't do it. Makes a huge mess. Missing this step makes life way harder, so don't do that. Cube root of 3, or cube root, sorry, of w minus 1 equals 4. So now I'm going to raise each side to the power, same power as the index of the radical, which here is a 3. So I'm going to cube each side. On the left, I'm going to get w minus 1. On the right, I'm going to get the perfect cube of 4. 4, 16, 64, right? 4, 16, 64, yep. So then I'm going to add 1 to both sides. I get w equals 65. And then I need to check it. If I put 65 in here, minus 1, that's going to work out. I'm going to get a positive answer. So we're all good. Try this one. Same idea. Move the 5 first. When you get finished here, the answer should be t is negative 10. Now, just because the answer is negative doesn't mean that's not going to work. It means you ought to check. So here, I'm going to get the cube root of negative 10 plus 2. Oh. Okay, that's going to be the cube root of negative 8, and that's real because the cube root of negative 8 is negative 2. Negative 2 plus 5 is 3. So don't assume that a negative answer is not going to work. You have to check in the problem that you are doing. Okay? All right, let's try this one. This one is crazy looking, but really it's the same thing. It just is written in a different form. So remember that the 1/4 power is the same as a 4th root. So I'm just going to rewrite this. I'm going to write 7 equals the 4th root of x plus 3 plus 9. Now I'm going to do just what I've done all along. I'm going to subtract 9 from both sides. I'm going to get a -2 over here equals the 4th root of x plus 3. I'm going to raise both sides to the power of 4. So on the right, I'm going to get x plus 3. On the left, I'm going to get -2 to the 4th power, 2, 4, 8, 16. It's positive 16. I'm going to subtract 3. And I'm going to get 13 equals x. Now I have to check. So if I put a 13 in here, so I get 13 plus 3, 4th root, that's going to give me 2 plus 9. Here's the thing. 2 plus 9 does not ever equal 7. Really, I need to get a -2 out of here for this to work, and that's never going to happen. Okay, because I can't get a negative answer out of a 4th root. So the answer here is that there is no solution. Okay, this is what I expect to see, or I expect you to write no solution. You can't just leave that there not finished and then tell me it works or not. You have to be clear. Okay, so you try this one. Works the same way. You are going to get x equals 82, and then you have to decide if it's a solution or not. Okay, but we're going to rewrite it the same way we did the last one. This is the same as this. Steps are the same. If you're stuck, go back and look at the last one. They compare, okay? All right, this one even more complicated. So we got some steps. So let's follow the steps. Okay, I'm going to isolate the radical the best I can. All right. I'm going to subtract the y from both sides. I've got 2 times radical 4y minus 3 equals 3 minus y. This is one where I'm going to run out of room. So now I am dividing both sides by 2 isn't really going to help my cause. It's going to be awful. So I'm just going to square both sides. That's a square root. All right. So what happens is on the left, I'm going to get 2 squared is 4 times just 4y minus 3 because it comes out of the radical. So that side, whatever. On the other side, though, this means 3 minus y times 3 minus y. It means FOIL. It does not mean 9 minus y squared. Not at all. So FOIL, I get 9 minus 3y minus 3y minus plus y squared. So I'm going to write that in standard form. Y squared minus 6y plus 9. Now I got to combine like terms and distribute and do all kinds of things. We're going to use all the skills we've been building all along. So I get 16y minus 12 equals y squared minus 6y plus 9. Now I'm going to move all that stuff that way. Minus 16y plus 12. Minus 16y plus 12. All right, on the left, I'm going to get 0. On the right, I'm going to have y squared minus 22y plus 21. Now you know what I need to do? I bet you do. I need to factor. I know I told you it's never going away. It's never going away. So let's factor. I need things that multiply to negative 22 and add to 21. So let's say negative 21, or sorry, add to negative 22 and multiply to 21. I'm going to use negative 21 and negative 1. Y minus 21, y minus 1. Now I'm going to use zeroth product rule, right? Y equals 0 equals y minus 21, 0 equals y minus 1, y equals 21, or y equals 1. Now I have to check them. Please, please, please. Okay? So I'm going to put in, I'm going to go back to my original equation, always the original equation, always, always, always. So I'm going to do 1 plus 2 radical 4 times 1 minus 3 equals 3. 4 times 1 is 4, minus 3 is 1. Square root of 1 is 1. Okay, so that all becomes 1. 2 times 1 is 2, plus 1 is 3. That checks. So this is good. And then I'm going to do 21 plus 2 radical 4 times 21 minus 3 equals 3. So let's see. 4 times 21 is 84, minus 3 is 81. So that's 81. The square root of 81 is 9. 2 times 9 is 18. 18 plus 21 is not remotely 3. So this one doesn't work. So this one is not an answer to my problem. Okay? We're going to do this one together. Let's try it. So let's see. I'm going to start with getting the radical alone. I'm going to add m to both sides. On the left, I'm going to have 2 radical m plus 3. On the right, I'm going to have 3 plus m. Just like before, I'm going to square both sides. So on the left, I'm going to have 4 times m plus 3. On the right, I'm going to square that 3 plus m times 3 plus m. It's going to get me m squared plus 6m plus 9, just like the last one, right? M squared plus 6m plus 9. That's just going to be 4m plus 12 over here. Now I'm going to move the 4m and the 12 over to the other side. All right, that's going to give me 0 on the left and m squared plus 2m minus 3 on the right. So that's going to factor. Let's see, m minus 1, m plus 3. Because those minus, that will make negative 3 and it'll add to 2. So I'm going to get m minus 1 equals 0 and m plus 3 equals 0. That means m is going to be 1 or m is going to be negative 3. So now I have to check them. So let's do that in red. 2 times radical 1 plus 3 minus 1 equals 3. Well, that's 2. 1 plus 3 is 4. Square root of that is 2. 2 times 2 is 4. Minus 1 is 3. That checks. 2 radical 3, negative 3 plus 3 minus 1 equals 3. Let's see. Negative 3 plus 3 is 0. Square root of 0 is 0. 2 times 0 is 0. 0 minus 1 is minus 1. That doesn't work. All right, so only one solution works here. All right, let's try another. This one is crazy looking, but actually it is not as bad as it looks. Here's the thing. Is this the one? Oh, I took them out. Go me. Okay. So we get to do something lovely here. This is actually one of those where you look at it and you go, ooh, this is easier. Here's why. Because I can't isolate the radical. I have radicals on both sides, but they're to the same index. What that means is I get to skip the first step and I get to go straight to raising them both to the same power of the index. I'm going to cube both sides. What that's going to do is make my radicals go away. So I get 2x minus 4 equals 1 minus 8x. Oh, happy day. That's way better. I'm going to move x's to one side and numbers to the other. It means I'm going to get 10x over here equals 5. Divide by 10. X equals half. I still have to check. I still have to check. I still have to check. So on this side, let's see. Cube root of 2 times a half minus 4 equals cube root of 1 minus 8 times half. Well, 2 times half is 1 minus 4 is negative 3. On the other side, I get 8 times a half is -4. 1 minus -4 is -3. Check. We're good. All right. Try this one. This one works the same way. In this case, oddly enough, the answer is -1/2 for y. Try it. See if you can make it work. All right. A couple more. This guy is right here, the most complicated version we're going to get. Okay? This is the height right here. So what you see is that I have 2 radicals on the one side and a number on the other, ruh-roh. So it's like I can't isolate a radical. I have this number hanging around. So here's what we do. We kind of do a combination of both things. We are going to move one of the radicals to the other side. I'm just going to move the one that was negative since it's a little easier that way. So on the left, I'm going to get 3m plus 1. On the right, I'm going to get radical m plus 4 plus 1. Now here's what I have to do. I have to square both sides. I have to get rid of the radicals. But it's going to be a little harder than that. Okay? So 3m plus 1 on the left, super great. But the other side, just like I had to before, I have to FOIL. Ooh, that's not a radical. Sorry, radical m plus 4 plus 1. Okay, so FOIL. So I get m plus 4 plus, where'd it go? Sorry, radical m plus 4 plus radical m plus 4 plus 1. Okay, so now I'm going to combine some stuff. I've got 3m plus 1 on the left. Over here, I've got m plus 5, 1 plus 4, plus 2 radical m plus 4s. Okay, I'm going to move what I can out of the way. Minus m, minus 5, minus m, minus 5. So on the left, I'm going to have 2m minus 4. On the right, I'm going to have 2 times radical m plus 4. Okay. In this case, it is really convenient. Okay, watch what's going to happen. This doesn't always happen, but it can. So I can factor out of a 2 on the left. 2 minus m minus 2 equals 2 radical m plus 4. What that lets me do is divide both sides by 2 and cancel them out. So that means on the right I have m, or on the left I have m minus 2. On the right I have radical m plus 4. And then I'm going to go through. I told you there were times we were going to have to square it again. And we have to square it again. Okay? So this side, circled in green right here, has to get FOILed again, squared. So m minus 2 times m minus 2, I'll do that up here, gets me m squared minus 4m minus 4. Okay? So on the left, I'm going to have m squared minus 4m minus 4 equals m plus 4. Okay? I'm going to move everybody over. Oh, wait, that's an m. I wrote an m instead of a 4. Sorry. Minus m minus 4. So I'm going to get m squared minus 5m minus 8 equals 0. I did something wrong. Oh, it's a plus. That's right. So these guys should cancel. Okay, there should be no 8. Yeah. Now, look at what you can do. You can factor. We can factor out an m. I still don't have a pen. Sorry. M. So I'm getting m minus 5 equals 0. So I'm going to set m equal to 0 and m minus 5 equal to 0. So m equals 0 or it equals 5. Now you have to go check. Okay? Go check. So what you're going to find is really quickly 5 is going to work. It's going to check. 0, if you think about it, this is going to be square root of 1 minus the square root of 4. 1 minus 4 is definitely not 1. So 0 is not going to work. Okay. Here is a second one like that. It is worth you sitting and figuring out if you can do this yourself. Please try it. Okay. The answer when all is said and done is, let's see, let me make sure I'm looking at the right page. 3c square root of 3c plus 1 minus square root of c minus 1 equals 2. When all is said and done, the answer here should be c equal to 5 and c equals to 1. If you are stuck, please talk about this one in the discussion. It's worth it. It would be a good conversation, okay? We are not going to do the next two. This section just gets really long. They're the same kind of thing over again, just more of it, okay? Here is some application of this, though. So for a pyramid with a square base, the length of this base B, so think about a pyramid with a square base. Oh, it's a terrible picture. I should draw the square first. Yikes. I have a square base that leads to a pyramid, okay? The length of a side of the base is given by this formula, 3 times the volume divided by the height, take the square root. The pyramid of Pharaoh Khufu, known as the Great Pyramid of Giza, has a square base. If the distance around the bottom is 921.6 meters and the height is 146.6 meters, what's the volume? Okay, so what they're saying is that I have the height and I have the distance around the base. Okay, now think about what they gave you. They really gave you a perimeter, right? I want this B as a side length. So the first thing I have to do is take 921.6 and divide it by 4. A square has 4 sides, right? So that's going to be 230.4. You have a calculator, remember that, right? And now I'm just going to fill stuff into the formula. I'm going to erase my beautiful pyramid here. I need that space. All right, so I know that this is 230.4 equals the square root. No, actually, you know, it would make more sense to do this before I put the numbers in, wouldn't it? So what I really want to do here is get V by itself. Okay, I want to find volume, right? So I have this formula, B equals square root of 3V over H, but I really want V alone. I have B. So I can reorganize this. That's the lovely thing about formulas. Square root of 3V on the top, square root of H on the bottom, right? I could, oh, even better yet, actually, I keep thinking about this in the wrong way, and then I have a good idea. It's not like I should actually look at my notes probably. You probably had this idea before me. I could square both sides, couldn't I? So I'd get B squared over here equals 3V over H. Now I can multiply both sides by H. So on one side I get B squared H, on the other side I get 3V divided by 3. So B squared times H divided by 3 equals the volume. I have all those things. I know that B, the length of one side of the base, is 230.4. I'm going to square that, multiply it by the height, which is 146.6. Divide that whole thing by 3. You have a calculator. You can do this. What's the volume? The volume's a big old number. It's 2,594,6. So it is 2,594,446 meters cubed. Okay, remember there are units for things, right? The area of the legs S of an isosceles triangle is S equals the square root of 2a, where a is the area. If the legs are 9 inches, find the area. Well, we're going to treat this one the same way. We're going to change the formula first. So let's square both sides. I get S squared equals 2a divided by 2. So I get S squared divided by 2 equals a. I know the length of the leg is 9. So 9 squared divided by 2 is 81 divided by 2. That's 40.6 0.5. So that's the area. That's in square inches. All right, 2 more quick things here. On a certain surface, the speed s of x in miles per hour of a car before the brakes are applied can be approximated with a formula. Find the speed of the car if its skid marks are 361 feet long. Skid marks are x. So first we're going to do s of 361. We're just going to put that in for x, 3.8 times the square root of 361. You have a calculator, please do that. Should get you about 72.2. Second question is, how long would you expect the skid marks to be if the speed was 50? Well, I have to use it differently in that case, right? I want to change the formula around a little bit. So basically what I have over here is I want to know 50, and I have 3.8 square root of x. Well, I'm going to divide first, get away 3.8. So 50 divided by 3.8 is something, right? I don't have my calculator handy, you have yours. But I know it's going to equal the square root of x. And to get rid of the square root, I'm going to square both sides. So put that in your calculator, figure it out. It should be about 173 feet. So if you're going 50 and you have to stop unexpectedly, your skid marks are going to be 173 feet long. It's crazy. All right, this is a final one. Try it if you like. For part number 9, the answer should be 3/2. Simplified. For B, the height is 48 feet. Give them a try. Pop into the discussion. I will see you there.